Okay, here's what we do on this, okay? Direct variation. As x equals 30 when y equals 2, x equals 5, what is y equals? Now, this isn't all that hard, but you got to pay attention. Direct variation. Here's what you do. You're going to set a proportion, but you're going to put x1, x2, and then y1, y2. Okay, just like that. Okay, so you got both your x's. You can put 30 and 5. Okay, x is 30, x is 5. Now, direct variation, y2 is the partner with x equals 30. So you're going to put your 2, okay, in for the y, and then you just cross multiply and divide. So you're going to take 5 times 2 is 10, divided by 30, just take the zeros off, it's 1/3. Okay, next one. This is how it's always set up. x1, x2, y1, y2. Okay. So your x's, you have 2 and 5, and then for the y's, you got negative, or no, wait a second, 2 and, I screwed that up. It's 2 and 5. No, 2 and 5's right. Okay. y1, you know that's negative 8, and then you cross multiply, and 5 times negative 8 is negative 40, divided by 2 is negative 20. Okay, next one, x1, x2, y1, y2. Okay, so you know you've got for your x's, you have 4, and x2 is 5, y1 is 12. So 5 times 12 is 60. 60 divided by 4 is 15. So 15 is your answer for the y2. Okay, x1, y, x2, y1, y2. All right, so what we have 1/2 for x1 and 5 for y2, and then 20. So 5 times 20 is 100, and then divided by half, you could also divide it by 0.5, that's 200. So that's pretty easy. Okay. Now the game's going to change because now we have inverse variation. By the way, I didn't explain at the beginning. Direct variation means as x increases, y increases. As x decreases, y decreases. But inverse is different. That means as x goes up, y goes down. As x decreases, then the y increases. So inverse variation means you go x1, x2, but then you flip it and it's y2, y1. Okay? So x1, x2, you got 30 and 5. And y1 you got 2, but we need to put it here. Okay? So 30 times 2 is 60, and then 60 divided by 5 is 12. Okay? So 12. So x1, direct inverse variations, x1, x2, y2, y1. You flip the other one. So you got 2 and 5. And then the y1 is negative 8, so we take 2 times negative 8, negative 16, then divide that by 5. That's negative 3.2. Okay, next one. x1, x2, y2, y1. So the x, you got 4 and 5. For y1 you got 12, so we take 4 times 12, which is 48, divided by 5. 9.6 is y2. And that makes sense because if you compare, remember inverse, the x's went up but the y's went down. Okay, that's how that's going to work. Okay. x1, x2, y2, y1. Okay, so x1 you got 1/2, you can just put 0.5, x2 you got 5. Now your y1 down here was 20, so 0.5 times 20 is 10, divided by 5 is 2. So y would be 2 because the x's went up, but then the y's go down. Okay, now story problems. That's what this is good for here. It says they're not hard, they don't take long, but you got to do one piece of critical thinking. An engine uses 6 gallons of gas when it runs for 7.5 hours. If it runs at the same speed, how many gallons will be used in 10 hours? Okay, so here's what you're going to do. You're going to make an XY table, and you would have your time be X and the gallons be Y. So leave yourself some room at the top, so you know you have 6 gallons in 7.5 hours. That's your X1 and Y1. Okay, and you have to later figure out 10 hours. You don't know how many gallons go with that. Now, if you had 0 hours, you'd have 0 gallons, so that means a proportion can be used. Okay, so here's what you're going to do. Instead of X1, Y1, you're going to put hours 1, hours 2. Now, you got to decide over here if it's gallons 1, gallons 2, or gallons 2, gallons 1. Well, think about it like this. Take the Y label, okay? The Y label, and then put the X label here. And ask yourself, if the gallons we need goes up, then we need more hours to run, okay? More gallons means we get more hours to run, so that's a direct variation. So that means we keep it in order. We go gallons 1, gallons 2. Okay, so hours, we got 7.5 and 10. Gallons, you have 6 for your first one, and we don't know the second one. So I take 10 times 6 divided by 7.5, and that's 8. So 8 gallons. Okay, next one. 6 bakers take 7 hours to produce the daily bread requirements of a bakery. Working at the same rate, how many bakers are required to produce the same quantity of bread in 5 1/4 hour? Okay, so you got hours, our X is hours, and then bakers is Y. Okay, so we know we have 6 bakers in 7 hours, and we have 5 1/4 hour. Okay, if you want to put 5.25, that's fine too. You're trying to figure out how many bakers. Well, 0 hours means we wouldn't have any bakers, so again, we're going to go like that. So instead of X1, X2, you're going to put hours 1 and hours 2. Now, before you write the labels down over here, okay, you're going to ask yourself, bakers. As those go up, the time it takes goes down because you have more help, okay? So that's an inverse one. So with its inverse, we're going to put bakers and bakers, but instead of 1, 2, we're going to go 2, 1. So X1 is 7, 5 1/4 here. Now Y1 is 6, but that goes to, a baker's 1's right there, so we put the 6 here. So we take 7 times 6 divided by 5.25, and that would be 8. Which makes sense because for it to take less time, we need more bakers. Okay, so 8's the answer. Okay, to fill a hole that is 10 feet deep, we need 55 cubic meters of soil. How many cubic meters are required to fill a hole that's only 4 feet in depth? So XY, this time it doesn't matter what your X unit is. We'll have that be, we can have that be cubic meters and feet be the Y. So leave yourself some room up there. We know we have 10 feet, 55 meters. And then we have 4 feet, and I'm trying to figure out how many meters this is going to take. Okay. Okay, now if 0 centimeters means 0 feet's needed, so that's what you have here. So X, put your CM1, CM2. Now decide what you have to do on the other side. As your feet go up, well, you're going to need more centimeters, okay? So that's direct. So when it's direct, we do 1, 2. So feet 1, feet 2. All right, so centimeters 1, we have 55, and we don't know centimeters 2. Feet 1, we have 10, feet 2, we have 4. So I take 55 times 4 divided by 10, and I got 22. So 22 is the answer. Okay, then the next one. Five students take 8 hours to type a paper together. Working at the same rate, how many students would be required to get the same length paper type in 3.5 hours? So you got X, Y. You have a time unit, that's your X, and then students is the Y. Okay, so what do you know? You know that you have 5 students, 8 hours, and 3.5 hours, and we don't know how many students, okay? So it's X1, X2, it'd be hours 1 and hours 2. Now decide if it's students 1, students 2, or students 2, students 1. It depends, okay? So write your Y unit and then your X unit. Now as the students go up, then the hours go down. So that's inverse. So over here we do students 2, students 1. Okay, this always works. Okay, so hours 1, you got 8 and then 3.5. And then students, and then right there, okay? Or no, my bad, that 5 should not go there. That's students 1, okay? That 5 right there is students 1, okay? That's Y1, students 1, so 5 goes here, okay? So 8 times 5 divided by 3.5 is, you would need 12 students to do that, okay? All right.